Okay, here we go. So, this is the second unit. I mean, this is the last unit that we're doing. We'll do two lessons, and then we'll break for SOL Tiger 3, and then we'll do 2 lessons after the SOL test, and then it's exam. No more copying key concept blocks because this is the last unit. And let's see. The second, the first one was all about like solving equations more than anything and introducing the radian measure in the unit circle. This one is a little bit more about the functions and equations. And this first lesson is about graphing sine and cosine. Mostly just about graphing sine and cosine. Our quiz, if things go as scheduled, will be on June 1st, and the test will be on June 7th. Okay, so here we go. So, we're going to go through the exercise of this anyways, which is that, there we go. Usually when you don't know what a function looks like, you plot some points and you graph it. So we're going to use values that we could just peel off the unit circle to make a graph, right? This is the x-axis, this is the x-axis and the y-axis right here. This is the y, this is the x. Okay, so, and I've already put all the radian measure angles here, because usually when you graph in radian measure. So at x equals 0, that's 0. At x equals pi over 4, I'm going to turn that into oh, actually that's not what I intended to do. I keep forgetting I'm doing it. In fact, let me change this. This is actually the y. So y is 0. At pi over 4, what's the value of y on the unit circle? No. What is the y coordinate on the unit circle? That's the sign, right? Root 2 over 2, right? So that's root 2 over 2. Right? At pi over 2, 1. At 3 pi over 4, root 2 over 2. At pi, 0. 5 pi over 4, negative root 2 over 2. Right? At 3 pi over 2, negative 1. At 7 pi over 4, we are at negative root 2 over 2. And at 2 pi, we're back to 0. So in order to graph these on the axis, I'm going to go from negative 1 is the minimum and 1 is the maximum. I know that on the x-axis, I need to be going from 0 to 2 pi. So this is going to be 2 pi. That makes this is pi. This is 3 pi over 2. This is pi over 2. Okay, now in order to know what where exactly to plot this, we should turn these into decimals. So there's only one there, really, root 2 over 2, which is what? It's like 0.71. Okay, so then this is a 1. This is another positive 0.71. There's a 0. Now we got a negative 0.71. Okay, then we get a negative 1. We get another negative 0.71. And then we get another 0. So now I can graph these, right? 0, 0. Pi over 4, which should be halfway through there, is 0.71, so maybe it's about right there. Pi over 2 is a 1. 3 pi over 4 is another 0.71. At pi, we're at 0. At halfway between pi and 3 pi over 2, we're going to be negative 0.71. Then we got negative 1, negative 0.71, and back to 0. So just looking at those dots, can we see the shape of the graph? Yeah, it looks like a wave. And that is what it looks like. Now, I could have kept going, I could have had 3 pi and 4 pi and all that, and to keep going that way, or I could have even gone this way, right? I could have negative pi. What would the graph have looked like if I kept going? same thing. It just keeps going and going and going, right? So what would that make the domain of a sine function? It's all real numbers. You know, it goes on forever. And the main thing being there's nothing that you cannot plug into a sine function. You're never going to get like an error because you plugged in the wrong thing. Okay, what is the range of that function? Yeah, it's got to be between -1 and 1. Like whichever way you would want to say that, right? The range can be, I'll write it up here. -1 is less than or equal to y is less than or equal to 1. Another way to say that, the absolute value of y is less than or equal to 1. Same thing. So that is called a sine wave. You can call it a curve, you can call it a wave. Looks the same in either case. Now, I really need to update my slides because I've got a lot of this, the old calculator emulator in here. And actually, we have new calculators. And it makes a little bit of a difference. So instead of just depending on this one here, I'm just going to show my calculator, my yellow calculator, so that we're all looking at exactly the same thing. I didn't know that I'd shut that down. Okay. Where's my yellow? So when you graph trig functions, you need to be in the right mode. So I think I got mine. That's pretty readable from right there. So I mean, we still look at the slides. So we want to go to the mode key, which is still just to the right of the second. You want to make sure that it's in radian measure. Mine is. That's good. So that we're all looking at the same thing. I mean, if I go to y equals right now, and I put sine x, just put a sine of x. Right, sine x. I hit graph. Well, I'm going to go zoom 6 to make sure it's standard. And you could definitely see the wave. But it's kind of like putting everything like really confined to the middle of the screen there. And you don't have like one perfect cycle of the wave going through. So what I like to do is like, let's set the window to be a little different. And so that's what I'm saying in the second image right here. Let's go to window key. Window key is right there, right? And let's let the x's go from -4 pi to +4 pi. So -4, and then you go second and the caret key, enter. It'll turn it into a decimal. And then we'll go to +4, second caret key. I'm going to make the scale in between, looks like I said to make it every pi. So let's go second pi. And then I'll let my y values go from -2 to 2. And the scale of that, I'll say, let the tick marks be every 0.5. Okay, now if I hit graph, it's going to change what we're looking at. So you can see now that it's going from -4 pi to +4 pi. So let's see. It goes, it starts at 0. It goes up to a maximum of 1, goes back to 0, minimum of -1, and back to 0. That's one cycle through, right? How many of those do you find from left to right? 1, 2, 3, 4, right? So, it goes through one from 0 to 2 pi. It goes through exactly one what you'd call a period, right? From 0 to 4 pi, you go through 2. Okay, so that's if you graph with the calculator, that's what you should do. I mean, you could set your window differently, but understand that you do have options. Like if you don't have to accept the fact that it's just like really close, and you just can't really see much when it's all packed around the x-axis. This spreads it out a little bit more. Okay. So when you're looking at there, and it looks like a wave. You copied some of this stuff in the key concept blocks. So you can see that the wave goes above and below a center line, which right now is y equals 0, right? The distance that it goes above or below is called the amplitude of the wave, right? In this case, because we didn't multiply the sine function by anything, it's just one sine of x, that means the amplitude is 1, right? If it was 2 times the sine of x, then it would go from 2 to negative 2, okay? The period is like how long, on the x-axis, how long does it take to go through exactly one wave? And the answer is 2 pi, right? From 0 to 2 pi, it goes through exactly one complete cycle. Okay. And actually, the reason for that is because inside the sine, it says sine x, but that's a sine of 1x. Now, the formula you copy down says that the period should be 2 pi divided by whatever that number is, right? So in this case, it's 2 pi over 1, 2 pi, right? If you want to change it, then you put in a different number as the coefficient of x inside the function. So these two terms are kind of important, period and amplitude. Okay. So if we have, like as a general formula, y equals a times the sine of bx. The amplitude is whatever you're multiplying times on the outside. In fact, it's the absolute value. So if we were multiplying by negative 2, the amplitude is still 2, right? It's not, the amplitude is always a positive number. And the period is 2 pi divided by whatever that coefficient of x is. Okay. So now if we compare the sine and the cosine graphs, and you could do that too. The difference, if you look at what I've got here, because I did it on this old calculator emulator where all the lines drawn were the same color, there was no way to distinguish between two graphs other than I would scroll into the left margin and I would hit enter once and it would turn the line into a fat line. But now you have different colors. When you do two different functions, they get a different color. So like if I go back to y equals, and then I'll go to the second line and put a cosine x, right, and then I hit graph, and now it's a red line. The first one's blue, the second one's red. I don't need to turn them like skinny line and fat line anymore. But what do you notice about the shapes of sines and cosines? It's the same shape, right? It just looks like the sine, which is the blue line, has just been shifted to the left, and it is. So how do you do a left shift when you're doing transformations of functions? Usually when you go to the left, you add inside the function, and that is true. So the cosine of x equals the sine of x plus pi over 2. You could do that if we go to the, where is that? X plus pi over 2. Go to y equals, and now I'm going to go plus second pi divided by 2. Right. And now when I hit graph, that's the first one, the sine of x plus pi over 2, and now here's the cosine, and it's right on top. So those are actually the same thing. Now, if you look at the, we know how to do a scatter plot or a regression line for a scatter plot. If you go to the functions that are available there, you scroll to the bottom, you see it, option C is the sine, right? You don't see a cosine. because you don't need another one, right? Because one of them is just a pi over 2 shift to the other. So they don't give you a cosine regression line, just a sine, because it's essentially the same graph. Okay, now if I go back, something that might be kind of important just to note here. Delete, graph. Is that if you look at it again on the blue line, right? The sine starts at 0, right? It goes to a maximum at pi over 2. It goes back to 0. It goes to its minimum at 3 pi over 2, and then it goes to 0 again at 2 pi. Cosine starts at its maximum, right? It starts at 1, right? Because the x-coordinate at 0 is 1. And then it goes to 0, its minimum, 0, back to its maximum. That's the whole thing. So we kind of use that fact a lot when we're doing the graphing. So here we go. Now the other functions, you don't need to copy this down because we're not going to do anything with these other functions. But there are graphs of the other functions, and they look kind of odd, you know. I mean, a sine wave, you could definitely say, hey, it looks like a wave. You might imagine things that you could use a function that keeps going up and down and up and down. But I think these kind of would stretch your imagination to try to figure out what process might use this kind of a thing. So I don't think these are near as practical. And you can see, like on the tangent function, remember when you have the coordinates on the unit circle, how did we calculate the tangent? It was y over x, right? Well, if x is 0, and sometimes it is, then you're dividing by 0, which means you have to have a vertical asymptote on the graph. So this one has got a vertical asymptote at pi over 2, and then so would the secant, because it's 1 over the cosine. There's a vertical asymptote right there. Right? Cotangent and cosecant have the y coordinate in the denominator, so this time it would have a 0 at 0 and pi and 2 pi. So that's where the vertical asymptotes are. So they're just shifted. Right? Remember the sine and the cosine. The sine goes from 0, which obviously is undefined there, to 1. 1 over 1 is 1, right? And then it goes back to 0, undefined. And then at 3 pi over 2, it's negative 1. 1 over negative 1 is negative 1. So, you know, and when it's anywhere between, the sine is anywhere between 0 and 1, then the cosecant would have to be more than 1 because you're dividing by a number less than 1. So those are all the trig functions. Okay, so let's graph one of these by graphing maximum and minimums and x-intercepts. So the first thing you're going to look at when you're graphing a sine function is what is the amplitude and what is the period. So in this case, the amplitude is the absolute value of that number right there, which is 4. And that's why I'm going to draw the scale on the left. It goes from -4 to 4. Right. The period is 2 pi divided by this number right there, but that's a 1. So it's 2 pi over 1 is 2 pi. So I'm going to label this because I said just for one period, right? That's all we're going to draw. I'm going to start it at 0, and I'm going to take it all the way to 2 pi. Right. So I can label in between, right? This is a pi. And I'm just going to leave it at that. We know that's pi over 2 and that's 3 pi over 2. So again, we know what the sine does. Sine starts on the center line at 0. It goes up to its maximum. It goes back to 0. It goes to its minimum. And it goes back to 0. Now, in this case, because of the amplitude, that's 4 and -4, the maximum and minimum, not 1 and -1. But can we kind of see the wave shape in that? You know, it said x-intercepts on there, but you might want to think of it less as an x-intercept as an intercept with a center line. Because when we've shifted this thing vertically, it actually won't be an x-intercept anymore. It'll be an intercept with whatever the center of this wave is. Got it. Okay, how about a cosine of 4x? Right. In this case, the amplitude is 1. But because of that 4, that's the coefficient of x, we've got to calculate a period now. The period is 2 pi divided by 4, which is pi over 2. So it's going to go through one complete wave between 0 and pi over 2. Right, I'll put in the pi over 4, which will be in the middle. Now, cosine starts, let's see, the amplitude is still 1, so it goes from -1 to 1. Cosine starts at its maximum, right? Then it goes to 0, then it goes to the minimum, then it goes back to 0, and then it's got to finish where it started, right? Because it's one cycle. And then that is one complete wave. Now, if I look at, I'm going to do this just for grins. Y equals. I'm going to replace the cosine on the first line. I'm going to put cosine of 4x. Cosine of 4x. And then I'm going to hit graph. Right? Because the period is shorter, it's going through those waves much quicker. That's the cosine of 4x, and there's the cosine of 1x behind it. Okay. So try to graph 2 times the cosine of 1x. Sure. So where is my... I'm not seeing. I can't see how to pause this thing. Locked. So unfreeze. No pause. So what's the amplitude? The amplitude is 2. What is the period? And the period is 2 pi. Okay, so let me label the y-axis from -2 to 2, the x-axis from 0 to 2 pi, and I'll put pi here. This is a cosine function, so I know that it starts at its maximum, drops to 0, drops to minimum, back to 0, or the center line, and up to its maximum again. And here we go. I mean, the thing you notice right now, because there's no vertical shift or horizontal shift, is these graphs all look the same. The only thing that's different is the axis and how you label the axis. But it's actually the same shape of graph, and that's quite true. Right. Now, again, you can look at it. Let's compare the cosine of x with 2 times the cosine of x. There we go. Graph. There's 2 times the cosine of x. And then here is 1 times the cosine of x. So the amplitude's bigger. Okay, next. So try this one. F of x equals the sine of pi x. I wish I could figure that out. What's the amplitude? 1. What is the period? It's actually 2, right? Because if you do 2 pi divided by pi, 2 pi over pi, you get 2. So I got to label -1 to 1 for the y-axis, and I go 0 to 2 for the x-axis. Okay, this is a sine function, so sine starts at 0, goes to its maximum, back to 0, to its minimum, back to 0. Okay. So here we go. Next. So 1/2. Now we've got 2 different things going on. Okay, what is the amplitude of this one? Amplitude is 1/2. Okay, the period will be what? It's going to be 2 pi divided by 2 pi, right? Which is 1. So we're going to label this -1/2 to +1/2. From 0 to 1. So this is going to be 1/2. Right? It's a cosine function. Where does the cosine start? It starts at its maximum. In this case, the maximum is going to be 1/2, right? The amplitude. Then back to 0, to its minimum of -1/2, back to 0, back to 1, and all the way up to 1/2. So frequency is 1 divided by the period. So like usually the period, on the x-axis, it's something like, a distance or a time or something like that. So let's say that it's in units of time, units of seconds. Then if you do 1 over that, then the unit becomes per second. Right? There's no unit in the numerator. There's only a seconds in the denominator, and that is a unit of time. I think on the next slide we'll see that's called hertz. Right? So this is, frequency, I think a lot of times we'll use this kind of f, lowercase f like that, is 1 divided by the period. I guess, to be clear, the period is like how long does it take to go through one complete cycle. So it's the amount of time it takes. So the frequency is then how many cycles per 1 unit of time. So let's see how that works out. I mean, the only reason I put that in there is because there's a problem coming up. Right? A sound consisting of a single frequency is called a pure tone. An audiometer produces pure tones to test a person's auditory function. Suppose an audiometer produces a pure tone with a frequency of 2,000 hertz cycles per second. The maximum pressure P produced from the pure tone is 2 millipascals. Write and graph a sine model that gives the pressure P as a function of the time in seconds. So at this point, we're going to be graphing something like this, right? P equals, there's going to be some number in front, that's going to change the amplitude. It's a sine function, they've already told us, right? And then it's going to be B times, and let's just call it T for time, since that's what they're giving us. Now we know the B helps us find the period, but they didn't tell us the period. They didn't tell us the B, but what did they tell us that we could use to find the period and the B? The frequency. That's why they told us on the slide before that frequency is 1 divided by the period, right? So that's why we're going to use that. So we're going to say that the period is 1 over the frequency, which is 1 over 2,000, right? Which is it says 5e negative 4, so that's 0.0005. 5 times 10 to the negative 4. Okay, that's the period. Okay, but we don't really just need the period. We need to know what's the B, right? So we know that the period is 2 pi divided by B. So maybe now we could use this to solve for the B. Right? How do I solve this for B? Kind of relates to solving those trig equations. So B should equal 2 pi divided by 0.0005. And I'm gonna leave pi as part of the answer. What's 2 divided by 0.005? 4,000. So B equals 4,000 pi. Okay, that tells us what we need to put there. Right. Okay, now amplitude. What can you tell about the amplitude? There's only one other number that's given there. Yeah, they say the maximum P is 2. So that's got to be that. Right? Because we know the amplitude just tells us the boundaries, between the minimum and the maximum. So here's the equation. P equals 2 times the sine of 4,000 pi t. Okay, if we were going to graph it, then we would need an amplitude of 2, so it goes negative 2 to 2. We already know that the period of this thing is where is this? Is the 0.0005. So we would know that it's going to go from, starts at 0, goes to its maximum, goes back to 0, goes to its minimum, goes back to 0. If you graphed it, let's say you left the scale the way we had it before, it'd be going, you know, because it's going through one complete wave and only 0.0005. Okay. Okay, here we go. So transformations of sine. Well, we've kind of done some transformations. I mean, you could call the multiplying times a is a stretch or a shrink. So that's already there. You know, the b is its own thing because, you know, period is something that we didn't deal with any other function. But we did have horizontal and vertical shifts of functions. And we'll have the same thing here. Now, sometimes we'll write this like this. It might be written like this: y equals a sine b times, I'm going to say it like that, bx minus c plus d. And we'll just use a, b, c, and d. But we're using the h and the k because that's what we used before, right? With the parabola, even with absolute value. And the h was the horizontal shift and the k was the vertical shift. The vertex was h comma k. So I use the same thing here, hk. Okay. So let's see. Graph this one. So we can tell from that right there that the amplitude is 2. We could tell that the period is 2 pi over 4, which is pi over 2. And what is the effect of adding 3 after the function? Up 3, vertical shift. So now, you know, the center line used to be right on the x-axis. Now the center line is not there. In fact, I'm going to draw this in. I'm going to draw that line in. I'll make it a dashed line if I can see it. That's the new center line. Okay, we know that it's going to have an amplitude of 2, so it's going to go from 1 to 5, right? If the middle is 3, it goes 2 below and 2 above. On the x-axis, it's going from 0 to pi over 2. Right? This is a sine function, so it should be starting on the center line at 0. It should go to its maximum, back to the center line, to the minimum, back to the center line. Graph. Yeah. Oh, did I do that wrong? Yeah, it should have been pi over 4. In my mind, I was thinking 2 pi on the right. Thank you. Okay, so try that one. Try to graph the cosine function, which has been shifted how? Up 4. What's the amplitude? What's the period? 2 pi, right? They haven't been changed because the A and the B are both 1, so it's still the same. Okay, it's been moved up 4, so it's gonna go in between 3 and 5. Okay, it's a cosine, so where should I start to plot? You start at 5, right? It's a maximum. And then you go back to the center line. You go to the minimum, back to the center line, back to the maximum, right? Okay. Graph. Okay, now we get a horizontal shift. So we could tell by this 5 right there that the amplitude is 5. We could tell by this 2 right here that the period is 2 pi over 2. And we could tell by this minus 3 pi that this is right 3 pi. So that's why I show it on the axis right here, a little like break in the x-axis, and I pick it up at 3 pi. That's shifting it to the right 3 pi. Okay, now the period is pi, so it's going to go from 3 pi to 4 pi. All right, this will be 3.5 pi in the middle. I'm not even going to show that. Okay, the amplitude is 5, so it's going to go between 5 and negative 5. And that's it. It's a cosine function, so it starts at its maximum. It goes to 0, to its minimum, back to 0, to its maximum. Okay. Okay, try that one. So what's the effect of the plus pi inside? Left. Okay. And what's the effect of the minus 1 after? Down, right? So again, I'm going to do this, and this is not a bad habit to get into. Like, because it's down 1, let me change the center line. It's kind of like when we were doing exponential graphs. we knew that there was an asymptote on y equals 0, so the first thing we did is move the asymptote, and then you draw the rest. This is not an asymptote, it's just the center line. Okay, so now it's moved to the left pi, so I'm going to start it at negative pi, and then it's going to have a period of 2 pi, so it's going to be back to 0 and over to pi. All right, this is the sine, so sine should start on the center line, should go to a maximum, to the minimum. I should have put a negative 2 here. To the minimum, oh sorry, back to the center line, and then to the minimum, and then back to the center line. Here we go. So, suppose you're riding a Ferris wheel that turns for 180 seconds. Your height h above the ground at any time in seconds can be modeled by, right, and there's the function. Graph your height above the ground as a function of time. So let's see. What is the 85 telling you? That's the amplitude, right? Amp. What is the pi over 20 telling you? Okay, so what is the period? What is 2 pi divided by pi over 20? $40? Do it. I mean, 2 pi divided by pi over 20 is like 2 pi times 20 over pi. The pi's cancel, 2 times 20 is 40. Okay, what about the minus 10 right there? That is right 10. And what about the plus 90? That's up 90. Okay, so let's see. Turns for 180 seconds. I didn't really do this before. It shifted 10 to the right. And so that should be in terms of seconds. So let's try to do it like this. So let's see. So 109. I'm going to make this 100, and this is going to be 200. That'll make 10. The shift of 10 to the right puts it about right there, and it's going for 180, so it's going to go up to 190. That's how much of the graph, I guess, they said that they wanted us to do. Okay, the vertical shift is up 90, so let me draw that line in there. So I'll make it up 90 is like this. So that is a 90. Okay, the amplitude is telling you how far does it go above and below that line. Okay, well, if it goes 85 above that line, then it goes up to 175. If it goes 85 below that line, it goes down as low as 5. So that means your head is 5 feet off of the ground. Okay, so pretty close to the ground. Okay, the period is 40, so it should go from 10 to 50 is 1. To 90 is 1, to 130 is 1, to 170 is another. Might have helped to have a better drawn graph. So let's see, it's a sine function, so it starts here, and we know in one period it's going to go to its maximum and to its minimum, and then back to there again, right? And then it's going to keep doing that same thing to its maximum and to its minimum, and to its maximum and to its minimum, and one more, to its maximum, to its maximum and to its minimum. So my spacing isn't real good, but it's doing something like this for 180 seconds. Okay, now, what are the maximum and minimum heights? Max and min. Right? The amplitude is telling you those two things. Okay. So, compare the graph. I'm not even going to do this on the calculator. What do you think if the sine function looks like this? What do you think the negative sine function would look like? Yeah, this should be a flip. Right? If that's the sine function, then the flip of it should be that. Now, if you take something like y equals negative sine x, what is the amplitude? Remember that the formula for the amplitude is the absolute value of the A. So in this case, it's the absolute value of -1, which is +1. So amplitude is always positive. And you can see that this thing is going above and below the line the same. It just doesn't do it when it did before. So it's changed it. Okay, so that's the last kind of thing that we add to this. We've already done stretches and shrinks and left and up and down, left and right, period changes. So same thing with the cosine. Right? I'll make this will be the cosine right there. Cosine goes like that. Right? What would the negative cosine do? It would start down here, right? It would go up to the top. It would come back down like that. So it's just a flip. Or you could say a reflection in the x-axis. So basically, if A is less than 0, the graph is flipped across the x-axis. I think we already got that point across. So we graph. Okay, am I back to blue? I am back to blue. Okay, what is the amplitude? Amplitude is +2. Okay, what is the period? What is 2 pi divided by 2/3? 3 pi. Okay. What is that -1/2 doing right there? It's going to the right, pi/2. Okay, and then what is the negative telling you to do right there? Flip. Okay, so the center line hasn't changed. We haven't gone up and down. I've already scaled the amplitude as 2 to -2. That's correct. It's starting 1 pi/2 to the right. That's here, right? So it should go through one complete period from 0 to 3 pi plus pi/2. So from there to there, right? And then this is halfway through. So the sign, it'll be at 0 in all those points. Not quite. Right? It's going to be at its maximum here. Actually, it goes down first. So it's going to go down, back to its maximum, and back. Right, that's got everything in there. It's got the amplitude of 2, the period is 3 pi, and it shifted pi/2 to the right, and it's flipped. Goes down first. Great. So try to do that one, and it's the last slide. What is the amplitude? Positive 1. What is the period? 2 pi, right? And what is the plus pi over 2 doing? Left pi over 2. So that's why I've got this mark already there. Negative pi over 2 is where it'll start. It'll finish at 3 pi over 2. And it's flipped. So where am I going to put the first point? Right, it's going to be here. As it cosine starts at its maximum, except for it's been flipped. So it's going to go like this. And there we go. And I should not have put that dot there. Okay, that's it.